So today we are going to move on the next topic, and that is about the E and ln. E means island constant and N means natural log. All right. E is basically a constant number, like you have a fixed value of pi, it is 3.14. At the same way, we have a value of E that is 2.7182, but obviously it has some properties, so that's why we are just going to be give them a special treatment, okay? And that is known as Euler's constant. All right. Now, the first property about this one, for example, if you are going to be take the derivative of Euler number, we are going to take the derivative of Euler number e raised to power any x, so that always be the same thing, because you know that if you have to take the derivative of any number, like you are going to be taking the derivative of x here, it is 2x, right? You have to take the power at the start and subtract one power. Yes, have you remember?
Yes, sir.
So in the same, but in this one, it will be just the derivative of e power x is as it is, and here you have to multiply the derivative of x, that is 1. All right. For example, if you are just going to take the derivative of e raised to power 4x, so it will be exact same e power 4x. But obviously you have to multiply the derivative of power, that is 4x. So you will get the final answer. Yes, the derivative of 4x is
4.
4. Yes, because the derivative of x with respect to x is 1, constant at the start, so it will be the final answer. Here we have the multiply with the derivative of their power, but we know that the power of the x, the derivative of x with respect to x is always 1. This is the first property. Now we have to talk about the graph. Okay, we already know that if you have any graph, like you have any graph of exponential, like you have 2 power x, you have 2 raised to power x, the shape of the graph is always look like this. It always passes from 1, because we know that if x is equal to 0, it will,
Sir,
yes.
can you quickly explain again the first point?
And this one,
No, the above one.
this one,
Yes.
I'm just talking about the derivative of exponential. We have a specific rule about the derivative, that if you are going to be taking the derivative of x power 1, you have to take the power at the start and subtract one power, right? But here
Yes,
we are
sir.
talking about in the island numbers. If you're taking the derivative of e, the derivative of e as it is e power 4x, it is as it is. Multiply the derivative of the power that you have on e, like this. That's it. I'm just telling you how you are going to take the derivative. So this is the very first property of the island number, that the derivative of e is exact e as it is. All right, the
Sir, we
derivative of
want
e is equal.
-1.
No, it is not. That's why I'm just telling you, we are not following this rule. The derivative of island number is as it is. E power x as it is, it's the derivative. There will be no change in the value, but multiply the derivative of their power. This is the thing I'm telling you. We are not following this rule here. This is a new
Okay,
thing
sir.
that I'm going to tell you. The derivative of island number is as it is. All right. Now we are talking about the graph. So the graph, you know that any number having the variable will be in the numerator. You have x0, so it will be 1. So always remember the graph is always going to be passes from 0, 1. All right. Now let me make the graph for exponential. These graphs we already done in P1, but here we are going to be talking about the respect to E. Okay, for example, if I'm just going to draw the graph like here, let's say this is the graph of y is equal to e power x. Y is equal to e power x. If I'm just going to make the graph of y is equal to e power 2x, y is equal to e power 2x, because 2, so obviously it is more exponentially increase the graph. So the graph will be more exponentially increase, but in the negative value, it is going to be less. It is going to be below. Just look like this. It is a straight curve, not like this. Now, for example, if you have a graph like you have y is equal to e raised to power 1 over 2x. Obviously, 1 over 2x is lesser than 1, so it is less exponential. So it moves from here like this way. So basically, the value that you have with x that tells you about the steepness of a graph. For example, you have a graph y is equal to e raised to power kx. So here the k is basically tells you the steepness of the graph. Is it clear?
Sir.
Yes, sir.
Now, for example, here I'm just going to be talking about with the positive power. It can be with the negative power. Let me make the graph with negative power. For example, if you have a graph y is equal to e raised to power minus x, so it is moving from left to right and passes from 1. All right. Now, if you have a graph y raised to power e power minus 2x, y is equal to, so look at here, it will be more steeper than e power minus x. So this is moving here. And after that, it will be cross, it will be low. And if I'm going to make a graph of y is equal to e power minus 1 over 2x, so obviously minus 1 over 2x is less steeper than minus x. So it is moved from here, but moves above after it. And what is this point? This is a point 1, because we know that any number having a power 0 that always be 1. So this is about the basic introduction about the Euler number, the derivative of Euler number, and obviously the graph of Euler number. All right. Yes, everyone. Any question?
No, sir.
No, sir.
All right. Let's see how to talk about a little bit more about the natural log. Okay, we have the basic idea about the log. The log is going to be look like this. If, for example, if you have only log of x, if there is nothing, means it has a base 10. It means that it is a base 10, but we did not show it. Like you have a square root, we did not write the 2 here, the same as if there is nothing, means it is a base 10. In the same way, you can make the log of any other base, like you have base 2 or base 3 or base 4, you can make it any base. Okay. In the natural log, basically, in the natural log, basically it is the log, but what is the base? The base is exponential, e. All right. Obviously, we have a log with base 2, log with base 3, log with base 4, log with base 10. All right. Normally, we have to use the log base 10 or log base e. If you have a log with base e, that is known as natural log. Yes, everyone. It is clear. What does it mean by natural log? A log with base
Yes.
e. Okay, we have some properties, obviously some properties because of natural log and some properties itself a log we have. We have to talk about that things. Properties. The first one, always remember, always remember, if you're going to be taking the natural log of any constant value, that always be zero. All right. Okay, before I have to go for it, I'm just going to be recall the exponential to logarithmic form. For example, if you have 2 raised to power 3, it is equal to 8. It is exponential form. If you want to convert into the log, so it is log with base 2 of 8. The answer is 3. All right. What we have done, we just going to be converting a value from exponential form to logarithmic form. Log with base 2 of 8, the answer is 3. In general form, we have to write it as the log with base a of b, the answer is c. So it can be written as the base a of c, the answer is b. Yes, everyone, it is clear?
Yes.
So you know that if any number
Yes.
having a power 0, that always be 1. So that's why if you have 1, means this power is 0. It will be e power 0 or any number having a power 0. Second rule, if you are going to be taking the natural log of e, we know that the natural log is basically with base e. You are taking the base of e with e, that always be 1. For example, if I'm just going to be converted, the natural log of e is equal to 1. What does it mean by? We have e power 1 is equal to e. The base of 1, the answer is e. We are writing that one here. So remember that if you're taking the natural log of e, that always be 1. Yes. Any confusion about the second rule?
No, sir.
Yes, Aisha, is it clear for you as well?
Yes, we're clear.
All right. The third one, if you're taking the natural log of exponential of power x, okay, always remember the exponential and natural log basically are inverse of each other. What I'm saying? Natural log and e are inverse of each other. So simply the natural log and e will be cancelled out. The answer would be x. The fourth point, the natural log of x is defined for positive value of x. Okay, can you please tell me any number of any power of 2 or any power of e? The answer you can get will be in the negative answer. Is it possible you have to take the power of e and you will get the negative answer?
No, sir.
It can never be positive. So that's why the natural log is defined for the positive value of x, not for the negative value. For example, if you're going to be taking the natural log of -2, so it is undefined. Okay, these are the properties and some rules with it as well. rules for simplification, let's say. Always remember in the natural log or in the simple log as well, okay, you have the two numbers, they are adding. It is not for only natural log, it is for any other type of log as well. If you have two logs and they are adding, so you can write these values in the form of multiplication. You are converting the two logs into single one. You're converting the logs into single log. If they are adding, so you can write into the form of multiplication. It is the same rule behind it, that if your two numbers are multiplying, having a same basis, so we have to add the powers. So at the background, the same rule is working. We have the two natural logs, they are adding, so we have to multiply the values. And same as if they are subtracting, what we will do? Anyone? If you have
Divide.
two logs, they are subtracting, so we have to be divide the values in single log. The next and one of the most important property, and that's why we are going to be use the log. That is the main purpose to introduce a log. Is you have a log of any x raised to power n. So he is has a property. He take the power at the start into natural log of x. For example, sometimes you are going to be get the equation 2 raised to power x is equal to 8, right? So you have learned the method that you have to write 2 power x and 2 power 3, so you will get x is equal to 3, right? Remember this method?
Yeah.
For,
Yeah.
let me change it. Let me make it 7. Now what you will do? You can't do it. So I need to be take this variable at the start. I just want to be take it down. So for that purpose, I'm just going to be introduce the natural log. I'm going to be taking the natural log or simple log on both sides. So it is going to be take at the start, natural log of 2. So natural log of 2 is multiplying here, on the side we divide. So look at here, I'm just going to be get the value. So if you have a variable in the power, you want to be take it down. So we are going to use the log, all right? So that's why it is one of the most important rule. Um, we are going to be apply it a lot of time when we have a variable in the power in the index or in the exponent. Yes, everyone, you get this point?
Yes, sir.
All right. The next one is that is also the most important, a little bit sometimes confusing. That is change of base. In the change of base, for example, if you have any logs and you want to change their bases, all right? Like, first of all, let me talk about in general. For example, you have a log of base a of x. I just want to be introduce some new base. Let's say b. So log of b divided by log of b. All right. Here it is base a. For some reason, I want to be change the base. So you have to be any base you want to be it. Log of b, log of b. In the numerator, it would be x. In the denominator, it would be a. Look at here, the base is changed now. You have to convert the log of a into log of b. Is it clear?
Yes, sir.
Yes.
And in this one, we are talking about the natural log. For example, you have a natural log of x. So that can be, you can change it into any base. Let's say you want to be change it into log of x with base 10 divided by, there is no need to be show 10, and log of base 10 of e. For example, you have a log of base 2 of 7x. Okay, just tell me any base you want to be change it. Just tell me any base you want to be changed from 2. It is log base 2.
So 5.
If you want to be make it 5, so log base 5, log base 5. In the numerator, it will be 7x. In the denominator, it will be base, that is 2. That's it. Now look at here, the base is changed.
Okay.
Right. Now the last thing is that I already told you, the e power x means exponential or Euler number, and natural log or inverse of each other. For example, if you are taking the natural log of exponential raised to power, let's say 4x, the natural log of exponential, we cancel out, the answer is 4x. Or it can also be you have an exponential and in the power natural log of 4x. So natural log and exponential will be cancelled out, the answer is 4x. All right, so anyhow, the value is going to be cancelled out. Yes, everyone. Any question?
No, sir.
No.
All right. Now this is all the basics that we are going to be talking about. We have to go for the question. Okay, now he says that solve the following equations, give your answer in exact form. We have e raised to power 3x plus 2 is equal to 5 e raised to power x minus 3. So we want to solve it. This means that we need to find the value of x. And I just told you we are going to be introduce this one to take the power at the start means, here I'm just going to tell you, we are going to be introduce the natural laws to take the variable power at the start, right? So look at here, we have the variable, the powers will be here. So I just want to remove it. I'm going to be taking the exponential on both sides. But before I'm just going to go for it, I need to make a simplification. We have e 3x plus 2 is equal to 5 e raised to power x minus 3. Look at here, e raised to power x minus 3 is multiplying. So on the other side, it will be, yes, anything is multiplying, but on the other side will be
Divide.
divide. Now they have the same basis, so we have to subtract the power. 3x minus x, it will be 2x. 2 minus minus plus 2 plus 3, it will be 5. Bases are same, so we have to subtract the power, so it will be 5. Now I just want to remove the exponential. So how I just told you, which is the inverse of each other, like you have a square root, you want to remove it, what you will take?
In lateral log
You have to
square.
take the square on both sides. So here we have an exponential, so I just want to remove it, so I'm going to be taking natural log on both sides. So it will be natural log of e power 2x plus 5 natural log of 5. This is cancel out, you will get that 2x plus 5 is equal to natural log of 5. So 2x is equal to natural log of 5 minus 5. X is equal to natural log of 5 minus 5 divided by. So I'm going to get the value. Because he says that in the exact form, so that's why I just write it. If he says that you have to find the answer in the decimal, so you can use the calculator. Yes, Mustafa, Ahmed, Aisha, is it clear?
Yes.
All right, the next question we have in the B part, natural log of 8x minus natural log of x plus 4 is equal to 2. Natural log of 8x minus natural log of x plus 4 is equal to 2. Definitely, we have to remove the natural log. For that purpose, we'll take the exponential. But before we have to take the exponential, we need to do some simplification. We need to be converted into the single log. So look at here, these values are subtracting. So what we can write it in the form of
Division.
division. Look at here, the two logs are subtracting, so we can write it in the form of division. So we can write it as the natural log of 8x divided by x plus 4 is equal to 2. Now it is in a single log. So now I'm just going to be taking the exponential on both sides. Taking it on both sides. So so everything will be in the goes into the power, okay? E power 2. So natural log and exponential will be cancel out. You will get 8x divided by x plus 4 is equal to e power 2. Now from here, I just want to make x as a subject. It will be 8x is equal to x into e power x. Not x, it is 2. Plus 4 e raised to power 2. So I want to make x as a subject. So take my x values on the one side of the equation. X into e power 2 is equal to 4 e power 2. Take x as a common. It will be 8 minus e power 2. 4 e power 2. 8 minus e power 2 is multiplying on the other side will be 2. So that would be my final answer. Yes, everyone. Any question till here?
No, sir.
No, sir.
All right. I also tell you about the exponential graph. Let's do the question about the exponential graph. Okay, now look at here. He says that you have to, on the same diagram, sketch the graph of e power x and e power 3x. We have to make a general graph. So let's talk about the A part. So first e power x would look like this. The next is e power 3x, so it is more exponential. Will look like this. Y is equal to e power 3x. That's it. And where it is passes from? It passes from y is equal to 1. And these lines are the asymptote line, okay? It is y-axis, but it is also the asymptote line. Asymptote line means the graph is going to be closer to y-axis, but it will never touch them. In the same way, we have to make the graph of y is equal to e power minus x and y is equal to e raised to power minus 7x. So in the B part, we draw the graph. In this one, the graph is moving from left to right because you have e power negative something. So it is moving from negative like this. It is y is equal to e power minus x. Now the next is y e power minus x. So it is more steeper. So it is like this way. This passes from 1. This y is equal to e power minus 7x. Yes, everyone. Any question till here?
No, sir.
No, sir.
Okay, now in the next question, he says that find in terms of E the gradient at x is equal to e for each of the following function. The first function we have y is equal to e power x. So obviously we have to find the gradient function means derivative. So let me take the derivative. So dy by dx, this derivative of e power x is e power x.
Or
Now
X.
he says that you have to find at x is equal to 3. So at x is equal to 3, you will get the derivative or the gradient function is e power 3. Now in the b part, he is going to be said that you have e power 5x. So again, we have to take the derivative, dy by dx. So e power 5x as it is, but multiply with the derivative of power. And derivative of 5x is
5.
5, e power 5x. Now at x is equal to 3, we are going to be get the derivative dy by dx is equal to 5 e 5 into 3. That will be 5 into e power 50. So this is how we have to find. Let me do one more. Let's say we have y is equal to 5 into e raised to power minus 4x. So I'm just going to take the derivative because I need to find the gradient function or the gradient of the value at x is equal to 3. So it will be 5 as it is. Because it is constant, we have to take the constant at the start. The derivative of e power minus 4x is e power minus 4x multiply by the derivative of their power, that is minus 4x. So e power minus 4x, the derivative of minus 4x is minus 4. So you will get that minus 20 e power minus 4x. Yes, anyone have a question till here?
No, sir.
Yes, Mustafa, Aisha.
No, sir.
No, sir.
Now we have to find the gradient at x is equal to 3. So add x is equal to 3 minus 2 into e power minus 4 into 3. That will be minus 20 e power minus 12. This is how we are going to be finding the answer. Yes, everyone. Any question?
No, sir.
In the next class, we are just going to be talk about the e power is basically if you have a positive power, so it is exponential growth, and if it is negative power, it is decay. And we are just going to be also talk about modeling of some exponential function. And at the last, we are just going to be transform the log into the straight line equation. Inshallah, we'll continue in the next class.